Good afternoon, and welcome to hand-wavy chemistry, where we do not delight in the details, but rather bask in the big picture. Today, it's problem time, where we answer chemistry questions. The questions for today relate to calculating the pH of an aqueous system. Before we get into the questions, I want to first describe what pH is. pH is a representation of the hydronium concentration in an aqueous solution. An aqueous solution being one which contains water. When an acid is placed in water, it can protonate the water molecule, producing H3O+, the hydronium ion. Now, the concentration of the hydronium ion can vary greatly depending on the system we're talking about. For a concentrated acid, it could be 10 or 20 moles per liter. But for a basic solution, one where there's very little acid left, we're looking at less than a trillionth of a mole per liter as the concentration. So with such a very wide range for possible concentrations, chemists use pH. Now, when we look at a concentration, we can represent it in scientific notation, where we put a single non-zero digit to the left of the decimal point, any other decimals that may be required after it, and then we write times 10 to the power of x. This tells us where we would have to move the decimal point. If x was a positive number, we'd move the decimal point that many spaces to the right. If it's a negative number, we'd move it that many spaces to the left. In mathematics, there is a function which brings that x down and makes that the number. This function is known as a log function. So, since we're talking about times 10 to the power of x, if we think about just 1 times 10 to the power of 2, if we were to take log of this, we would get 2 as the answer. If it was 1 times 10 to the negative 5, and we took the log value of this, we would get negative 5 as the answer. The P in pH means take the negative log, in this case of the hydronium concentration, which that H represents. The reason it's a negative log is most of the time that value that the 10 has been raised to is negative. So rather than having to deal with a whole lot of negative values representing the concentration, we take the negative log, which gives us positive numbers. This is why the pH scale at first can seem a little bit inverted, with a low pH, meaning acidic, and a high pH, meaning basic. And that's because when the pH is high, the concentration of the acid was very low. And when the pH is low, the concentration of the acid was high. So now let's jump into some questions. The simplest style of question related to pH is one where we are just given the hydronium ion concentration. For example, in this first question, we are asked what is the pH of an aqueous solution with a hydronium ion concentration of 1 times 10 to the negative 3. As long as you know which buttons to press on your calculator, you will be able to get this style of question correct. The nice thing about the way that the log function works is that we can also get a rough idea of what the answer should be before we even touch our calculator. And in this very first question, we won't need a calculator at all. Remember, pH equals negative log base 10 of the hydronium ion concentration. It linearizes powers. So this number here is going to be close to the answer for the log of the hydronium concentration. Or in this case, it's going to be exactly equal to it because we have a 1 out the front. So it's going to be equal to negative, and the value for the log of this number is 3, so it's going to be 3. We can look at that power and know approximately what the answer is going to be, or in this case, exactly what the answer is going to be. For the next question, we can again have a rough guess because we can look and we can say, oh look, -5. If that was 1 times 10 to the -5, the pH would be 5. But it's not. It's more than 1 times 10 to the -5, so the pH is going to be less than that. So we can guess that the pH for this should be approximately equal to 4 point something. So we're going to get our calculator. We're going to take that pH equals the negative log of 4.2 times 10 to the -5. And if you put that through your calculator, you'll get an answer of 4.4. This double checking and being able to roughly guess is important because there are other log functions on your calculator. For example, there is the natural log written as Ln. This one linearizes powers of e to the power of something. So if we had e to the power of -4, then Ln of e to the -4 would be equal to -4. If you use the wrong log function, you're going to get the wrong answer. So make sure you know which button to press on your calculator. We could also be asked to do the reverse type of calculation. For example, what is the hydronium concentration for a solution with a pH of 7.3? Let's remind ourselves what pH stood for. pH was negative log of the hydronium concentration. So in order to find the hydronium concentration, we can rearrange this equation to find that it is equal to 10 to the power of negative pH. So in this case, we're going to put in here 10 to the power of negative 7.3. And if you were to put this into your calculator, you will find that it is equal to 5.0 times 10 to the -8. And this answer looks sensible because if we look at this exponent here, the -8, if this had been 1 times 10 to the -8, then the pH would have been 8. It's more than that, so the pH should be somewhere between 7 and 8, which it is. It's 7.3. One way that a pH type question could be slightly complicated is by not explicitly giving the hydronium concentration or the pH. For example, in this question, we are asked to calculate the pH for a 0.15 mole per liter aqueous solution of the strong acid HCl. Being a strong acid, HCl fully dissociates in water. So the hydronium ion concentration is going to be the same as that concentration of HCl. So let's write that down. The concentration of H3O plus is equal to the concentration of HCl, which we are told is 0.15 moles per liter. If we were to put this into standard notation, it would be 1.5 times 10 to the -1 moles per liter. Now we know that pH is equal to negative log of the hydronium concentration. So it's going to be equal to negative log 1.5 times 10 to the -1 moles per liter. And we could have a rough guess here that because we've got that times 10 to the power of -1, the pH should be somewhere between 0 and 1. And indeed, if we were to put this into our calculator, we find that the pH is equal to 0.824. Now our final question has a little bit of a trick to it. As in, we could very quickly answer it without having to do any calculations. The question says a strong acid solution with a pH of 2.4 is diluted by a factor of 100. What is the new pH? Now, the long way to do this question is to recall that the concentration of H3O plus is going to be equal to 10 to the power of negative pH, which in this case comes out as being 3.98 times 10 to the negative 3. Diluting by a factor of 100 changes this negative 3 to a negative 5. That is by simply dividing by 100. So we could now find that the pH is equal to negative log 3.98 times 10 to the negative 5, which equals 4.4. Now, I started by saying there's a little bit of trick to this, which is that because we are working in base 10, if we dilute by a factor of 10, pH will shift by a value of 1. Dilute by a factor of 100, it shifts by 2. By 1,000, it would shift by 3. So we didn't actually need to calculate the hydronium concentration, then divide by 100, and then convert back to pH. We could have simply gone, oh, it's diluting by 100. That is a power of 10. The pH will shift by some whole number amount, in this case by 2. Now, I mentioned that P before the H in pH meant negative log. And that P shows up multiple times throughout chemistry. And it always means negative log. For example, if I said POH, it would be negative log of the hydroxide concentration. If I said pKa, it would be the negative log of the acid dissociation concentration. But that is a story for another day. I hope you have enjoyed this video. And if you have, please make sure to like, subscribe, and share it with your friends. And if there are any questions you'd like to see answered in a future problem time, please put them in the comment section below. Thank you, and I hope you have a wonderful rest of your day.